Welcome back, everyone. So today we're going to look at the profit function and look for a very, very special point. It's called the point of diminishing return. So how does one find the point of diminishing return? Well, the point of diminishing return, you just got to flashcard it, the point of diminishing return is a potential inflection point. So i.e., I look for where the second derivative is equal to 0, and I evaluate all inflection points to find this very particular inflection point called the point of diminishing return. What do I mean by that? Well, let's take a look at this analysis to kind of give us a hint. Since the point of diminishing return is when the second derivative is equal to 0, I need to get the second derivative. So, all right, we need the first derivative, which we all can hopefully take this first derivative here. Negative 3t squared, right? Bring the power down, subtract 1. Same thing here. Bring the power down, subtract 1, 12t. Derivative of 50t is 50. Awesome. If I wanted to find max or min points, I'd be looking in here. To find max or mins, you look at the derivative. We're not doing that today. If the question says find the point of diminishing return, don't waste your time there. Move on to the second step, the second derivative. The second derivative is negative 6t plus 12. There's your second derivative. To find a potential inflection point, and a special inflection point is a point of diminishing return. We'll get to what it is, okay? I'm just trying to find it first. First we find it, then we talk about it. So we find it by setting it equal to 0. So we set this equal to 0, and then by good algebra, I get t is 2. And t is a time variable, so time is 2. If there was a negative variable, a negative answer, I would have thrown it out because we're looking at time, and typically time is usually above 0, 0 or above, at least for profits. So again, how did I solve that? Subtract the 12, divide the negative 6. Good algebra. So there's the 2. Now, is that a point of diminished return, or is that just a good old inflection point? Or is it nothing? The answer is, like I always do, and if you look at all my videos, I always do the same thing. The derivative equal to 0, build the chart. To me, the chart tells me everything. So what do I do here? I pick a number before 2, like 1, and I know I just made that x, let's make it t. Pick a number after 2, like 6. What do I do now? Now I plug them into the derivative. Not ooh, I apologize. I plug them into the second derivative. Remember, we're analyzing the point of diminished return. Please, everything goes into the second derivative. So we plug 1 into the second derivative, we get a positive 6. Don't care about the number, care about the fact that it's positive. I plug 6 into the second derivative, I get negative. Again, I don't care about the number I get, I want to know more about the sign. The sign tells me everything. The idea is always the same. This is the only point where the second derivative is 0. If it's not 0, it's got to be positive or negative, and that's what this analysis allows me to say. And I can pick any numbers I want for the numbers in green. Now, I got to learn my vocab. If the second derivative is positive, my function is concave up. My function will be concave up. If the second derivative is negative, my function will be concave down. So what I have here is a stick figure of my picture. I know my picture is concave up, then concave down. So it's definitely a point of inflection. Is it a point of diminished return? Well, let's talk about that. First of all, what does it mean to be a point of diminished return? That's a very good question. So first of all, let me stick these two together. Because really, this cubic is really, if you look at this, if you stick these two things together, you get the cubic in general. You get a parabola snapped to another parabola. And when you graph the profit function, you'd get this. Okay? When you graph the profit function, you get something like this. I've distorted it a little. So you might be saying, since I can graph, why do I care about this analysis? Very good point. The answer is, this point is not yet readily found in the TI calculator. It is, but you got to be smart on how you'd get it. To me, it's readily available in algebra and calculus, the point of diminishing return. Where is it? It's right there. And I'm saying it's a point of diminishing return. Why? Well, a point of diminishing return is when the rates start slowing down, the rates of growth. See, when you're concave up, your slopes are always increasing. That's what concave up really means. As you keep going, the slopes are increasing. Notice this, the slopes are increasing. My values are increasing. It's turning up. At this point, what happens? At this point, so let me clarify again. This is definitely a point of diminishing return. The reason I know is because it goes from concave up to concave down. That's why I know it's a point of diminishing return. If you go from positive to negative, you are a point of diminishing return. So this is definitely the point of diminishing return here, because I went from positive to negative. That's the short answer. The real answer is because of the graph. The point of diminishing return is all about the growth here. The slopes are all increasing. That's how you get a minimum. Your slopes are turning around and increasing. To get to a maximum, that growth has to sooner or later turn the other way and slow down. To get to a maximum, the slope has to turn down. And that's important. A point of diminishing return means sooner or later a maximum is coming. Right? That's really what it means to me, is sooner or later it's going to get to zero. The growth is going to go from positive and start turning to get to zero. This is a great predictor for us in stocks. If we can find the point of diminishing return, we know it's about time a maximum's coming. We might want to jump and sell our stock at the high point. All right? A point of diminishing return is very important to us in business. So let me back it down and summarize. If I want a point of diminishing return, what do I do? Second derivative equal to zero. Got it. That's not enough. It's second derivative equal to zero, and you go from positive to negative in the concavity. It's a very special concavity flip. If it was negative to positive, that's just a regular point of inflection. Still important, a still inflection point, but not a point of diminishing return. A point of diminishing return, flashcard, boom, second derivative equal to zero, and positive to negative in the concavity. Thank you guys for watching this video.